Hello. So we are getting into chapter 6. In chapter 6, we kind of get to leave a lot of that trick behind from chapter 5 and chapter 4. And I can't say we totally leave it behind because it's very still active and relevant in chapter 6, but it's not going to be in that same kind of context as it once was when we were in chapter 5 and chapter 4. In those two chapters, we had a lot of different verifying trig functions. We used a lot of trig identities, a lot of the unit circle. In chapter 6, most of that becomes irrelevant to us. While we will still have sine and cosine come up a lot in this chapter, it's all going to be calculator based. Okay, so we will not have to actually be verifying anything or using those identities. It's going to more just being able to work with sine and cosine and their inverses within our calculator. Okay, so today we are using law of cosine. So I'm going to draw an example up here. Oh, that one doesn't work. Of a triangle, and I would ask you, using what you know, would you be able to find, this is a 4 by the way, the layers right there, would you be able to find the hypotenuse of this triangle? Hopefully right away you're kind of saying, well yeah, it's a right triangle, I have 2 of its sides, I could find its third side by using Pythagorean theorem. So Pythagorean theorem only works when we're dealing with a right triangle. So what about a triangle like this? And this, I'm not labeling anything right angle. Sometimes it's harder for me to draw a triangle that doesn't look like it almost has a right angle, but I'm not labeling anything as if it does. Okay, so this kind of triangle is actually going to be called an oblique triangle. And in short, this is a triangle with no right angles. Okay, and there's a more kind of in-depth definition of this, but in short, it really is just a triangle. It's not going to have any right angles here. Hey guys, remember now? Sorry, my wet dog just came down. Do you want to say hi? Come here. Here. Baby. Oh, here you go. This is like so hard now a little bit. Oh, don't yell. Okay, so in this oblique triangle, because it has no right angles, we are not able to use Pythagorean theorem. You can only use Pythagorean when you have a right angle within that triangle. So when I ask you to solve this triangle, you're going to have to use what's called law of sides. So let's label this triangle out. Whenever we are talking about its angle measures, we use uppercase letters. Okay, and now let's label exactly as how I'm labeling this. We go counterclockwise in labeling. Okay, so it doesn't really matter exactly where you're starting with this. What does matter is that when you label its side, it's going to be directly across from its angle, its corresponding angle. So A corresponds with little a, then they should be directly across from one another. B across from little b, or side length B, and C across from little c, side length C. So when you're doing law of sine, the actual equation for this is little a over sine A equals little b over sine big B equals C over sine big C. So you really only need, you will not be using all 3 of these at the same time, right? It's improper to have 2 equal signs within the same function. So you will only be using 2 of these paired up at the exact same time when you're trying to solve. On top of that, what's going to help us be able to solve is having one entire pair. So a corresponding little b with a big B. If I have both of those things, I can use them to solve the rest of the triangle with one other measure. So when I give you this, I would not give you a big A, a little c, and a little b. That would not be any way that you'd be able to completely solve this in the end. And if there is a way, it's not going to be that obvious way that I want you to kind of have here. So I will always give you a corresponding little a, corresponding big A, little b, big B, little c, big C, or a way to find that corresponding pair and then implement law of sines. So if we jump into an example here, we'll label this triangle out. I want you, oh, and one other thing. While this is one version of law of sine, the reciprocal is also true. So it would also be true to say that sine of A over A equals sine of B over B equals sine of C over C. Okay, that is also true for law of sine. So it's important to remember that we have both of these versions, and we will be able to discuss when best to use each of them. Starting off, we're going to stick with its normal version where we have the side lengths on the numerator of this. Okay, so we grab favorites real quick. Okay, I want to solve the triangle. I want to solve where, oh, this one doesn't work either. Where C equals 102.3 degrees, B equals 28.7 degrees, and B equals 27.4. So another thing on this is if you're ever unsure of what is that a big C or a little c, it's obvious for B and A, but if you're not sure whether or not this is a large C or a lowercase c, you can always say, well, it's got a degree sign. Because of this degree sign, it's got to be an angle. We know the angle numbers are represented by uppercase letters. So if I kind of try to draw this out here, my triangle representations are not always the best, but we have a BC, ABC. Angle C is 102.3. Angle B is 28.7. And side length B is 27.4. Okay. So what I'm looking at is I can kind of see here that I do have a B and a big B matching pair here. So I have corresponding letters. So I have this entire ratio, which is a good sign for me because if I have that entire ratio, I can go ahead and find the rest of my side lengths and angle measures. One easy way to find a third angle measure are knowing two of those angle measures. We know that a triangle adds up to 180 degrees. So it's super fair to say that if I take 180 and subtract the sum of the two angle measures that I already have, that's going to be equal to my last and final angle, the angle A that I'm missing here. Again, I already have these two angles. Their sum subtracted from 180 is going to be that last angle measure. So I have 180 minus 131 gives me an angle measure of 49 degrees for angle A. Okay, so that's that last angle measure. Again, when you have an easy route like that, go ahead and take it. There's no harm in taking that last angle measure really quickly by just using what you know about triangles. Now what I'm going to say is I do know my big A, I know my big C, I need to find little c and little a. So I'm not going to use this one. It's going to be a little bit harder for me this time. What I am going to just first start out with is finding little a. Finding my side length A and side length C is going to be equally as complicated or equally as easy. Like no one is harder than the other. So it doesn't matter which one I choose first. If I go with angle A, or side length A, I don't know that. What I do know is that my big A is 49 degrees. And this can be set equal to what I know about side length B, which is 27.4 over sine of angle B, which is 28.7. Notice I just need to solve for A within this equation. In order to do that, I need to get rid of sine 49 in my denominator. When we want to get rid of something that's in our denominator, we simply have to multiply by it on both sides. So over here, sine of 49 is going to cancel. On this side, I'm just going to have sine of 49 multiplied on. Okay, so for lack of wanting to rewrite this, because I don't want to room, we're going to go ahead and erase what's gone now. The sign of 49 has been canceled out and just set equal to A now. Okay, so what I need you to do is first things first, go into your calculator. Okay, you need to go to the mode button. The mode button is right to the right of your, whatever, your second button. If you go to mode, you have to go about 4 things down where you see radian and degree. I need you to have the highlight over the degree. So if it's not highlighted black over the degree, you need to use your arrow key and then enter on degree. If it's in radian mode, you will always get incorrect answers for this. So making sure that you go over and put your calculator in degree mode. Again, this would be something that I would say go make sure your calculator is in degree mode before calculating this. If that's what I ask you to do, I would ask you to go into mode and going and making sure that it's highlighted over degree. Once you have done that, you can simply go put this immediately into your calculator. Again, using 27.4, and make sure you have these parentheses around it. I want one parenthesis here, and one parenthesis here. We want to take the quotient before we take the product of that quotient. Okay, so 27.4 and then division sign. Then you go type in the sign button. Again, sign is on your calculator. You're going to see sine, cosine, tangent. You just hit that sign button. When you do, it's going to open you up to a parenthesis. So ensure that you close that parenthesis and then close the second larger parenthesis. Then sine of 49. Again, it's going to open you up a parenthesis. Make sure that you close that. If you are doing this correctly, you should get an approximate A value. Again, I say approximate, meaning you're going to be rounding this a little bit. So I'm going to put the squiggly equal sign there. Let's see, I've got one of 43.06. This one, a value of 43.06. So we can look at this exact same thing for C. I can say C equals sine C over B sine B. I'm going to go fill in the things that I do know. So I know that my C is 102.3, my B 27.4, and my angle measure B 28.7. So again, when we want to get rid of something within our denominator, we multiply both sides by that value. So multiplying both sides by sine of 102.3, meaning we're going to have that quotient, then multiplied by sine of 102.3. You can just barely not see it. There you go. And on this side, that cancels out. So I only have C left, no C left on this side. Again, go ahead and put this in your calculator. If you did it correctly over here, it's essentially the exact same steps. With a parenthesis, type in this quotient. You will get 2 parentheses around that sine 28.7 value. Making sure you close off both of those parentheses before entering sine of 102.3. If you're doing this correct, you get an approximate C value of 55.75. Okay, 55.75. Okay, that would be the last value that we need. After getting our A value of 44.06 and then C of 55.75, this triangle would be solved for completely. Because when we say solve for a triangle or solve the triangle, it's saying we want to find the value for every side length and every angle measure. We've now done that by finding the last 3 remaining values, 1 being an angle measure, 2 being side lengths. Okay, so this is when you have 2 angle measures given and 1 side length given. Let's say, for instance, that they may have left out, maybe I was given the following. So let's backtrack a second. What if I was given a B side length and do that. What if I was given the following measurements when I asked you to solve the triangle? I gave you a C angle measure, an A angle measure, and a B side length. You could still perform all the actions that you needed to in order to solve this triangle. You just would have first had to have found your B angle measure, and then once you found this, you could go into law of sine. So the same kind of steps, but a lot of people freak out when they see one like that, because I'm like, we've always said that we need to find, that we need to have two corresponding values, a B and a B, or a C and an A in order to use law of sine, which you do, you need that. Sometimes it's not obvious to you. Sometimes you have three measures that aren't any pairs, but you do have a way to find that last pair without using law of sine, then be able to implement law of sine. Okay, so that's one different kind of method you might see. All right, so that's that for that kind of example. All right. So another example you might see, I want you to solve the triangle given that little a equals 22, little b equals 12, and big A equals 42 degrees. So again, super generic triangle. These are not accurate, drawn to scale whatsoever. This is A, B, C, B, C, 12 degrees. Actually, I'm going to do those in a different color so you can kind of obviously see what we have. We know B length, we know A length, we know A measure. Okay, so starting off right here, I do have a corresponding pair. So I do have the same ratio for A and A. So what I do know is that I have A over sine A. Another thing I have is my B value, but I do not have my angle measure. So this was a little bit different. I only have one angle measure, so I'm not able to find the other two without having a second one. Okay, I can find a third angle measure, but I can't find my second and my third until we have that one angle measure. But since I do have this ratio here of A over A, I'm able to use law of sine. So let's fill in the pieces that we know. I know my little a value is 22. I know that my sine of A is 42. And I know my B measure of side length is 12. The thing that I don't know is sine of B. Okay, that's the piece that I don't know. So didn't we say, though, that you could use the reciprocal version of this? So we said that it's not only true that the side lengths over the sine of angle measures was true, but you could also use sine A over A and sine B over B. That law of sine also still holds true. So an easier way to do this would be using the reciprocal version. Okay, I told you you'd kind of see an obvious difference between when to use the normal and when to use the reciprocal. This would be that obvious way to use the reciprocal. Because of the fact that I have my unknown value, or that B, in my denominator, it just makes it a couple extra steps for me to have to solve for that B. Versus when I do this, my B, unknown B value is going to be my numerator. Makes it super easy for me to just multiply over my side length B and then just be able to solve from there. So not that it's incredibly easier, but a couple less steps for me. So I'm going to go ahead and use that. So again, let's say my sine of A, sine of 42 over 22, and I don't know sine of B, but I do know my side length B is 12. So what I can do here
is I want to get rid of this 12, so I multiply it over. Multiply 12 over both sides. Here it cancels. So I get 12 times sine of 42 over 22 equals sine b. Okay, I need to go grab my calculator really quick, so kind of study that word. So let's see. Go ahead and put this part into our calculator. So 12 times, with that parenthesis, sine of 42 divided by 22. So what I am getting for that sorry, my own calculator wasn't free. Oh, here we go. Okay. So when I put this in my calculator, this side right here, I get 0.36498. Still set equal to sine b. So the issue here is I haven't actually solved for b. I solved for sine b. But I somehow need to figure out how do I get rid of this sign. So it's not as easy as just dividing it up. Okay, that's not actually going to take away that sign. That's one of the big things I want you to remember. You cannot divide off a sine or a cosine or anything like that. What you can do is take an inverse of that function. So if we multiply both sides here by this inverse sign, it will actually get rid of it for us. So sine inverse on this side is going to cancel it out. But remember, I have to take sine inverse of both sides. So I also have sine inverse of 0.36498 and so on. That will be what my b value is. So you need to learn how to put this in your calculator. It's actually very simple. All you need to do is go to the second button and then back to your sine. You're going to see it says sine to like the -1. That's sine inverse. So sine for -1 means sine inverse. Then you can do one of two things. I'm going to go scroll up to my previous answer and hit enter, and it automatically inputs that entire decimal for me. If that's not something you want to do, as long as you get a decent amount of that decimal there, or at least round it properly, you'll still get very close to that same accurate answer. Go ahead and press enter, and I get a total b value. I'm going to write it over here because we don't have a room. Of 21.406. Okay, so that is the degree measure. Okay, that's a degree measure. So let me come up top and put that up. 21.406. And you could even just round that to 21.4. I'm okay with that. Okay, so that helps us out a lot. Now we can find that third angle measure by taking 180 minus the sum of 42 plus 21.4. That's going to be your angle measure C. So you should be getting a value of 116. And again, this will be a little bit different depending on how you rounded. But I'm getting 116.6. Again, it's going to be all a little bit different for that decimal, depending on how you rounded that decimal off. Anything close, that's going to be okay, though. Okay, so again, 116.6 for me. The very last thing I need to do is find my side length C. So now that you know that you kind of learn how to do it either way, you can do one with only using 1 degree measure, using this reciprocal version, or you can come back to the normal version where you have those side lengths on top angle measures in your denominator, and we're going to find that C length. I'm going to come back to how we did it right here with the original version of law of sine and solve it through with my two angle measures. Okay, this time the only difference is I'm solving for C. So I will have A over sine A equal to C over sine C. Filling in what I know, my A length is 22 over sine 42 equal to, I don't know my side length C, but I do know that my angle C is 116.6. So if we keep following through like we have been, we multiply each side by that denominator to get rid of it. We're going to multiply by sine 116.6. That gives me sine of 116.6 times the quotient of 22 over sine 42. And again, that's going to give me my actual C value. So again, plugging that into your calculator to get out this side length, you should, let me put it in my calculator as well. $29.39. So up here, 29, sorry. 29.39 for that last side length. Okay, so if you gotta go back up to our triangle here, we solved it because we have all three side lengths and all three angle measures. So a little bit different thought process to this one, but not anything too much more complicated. Just using what we know about law of sine and its reciprocal and that triangles add up to 180 in order to solve that one. The very last thing here that we'd like to be able to do with this is stemming off of the law of sine. We have a way to find the area of a triangle. And that's going to be a totally different formula here. Okay, so finding the area of an oblique triangle. You're going to have three different versions. And this is all going to be dependent on what measurements you are given. So the area can be one of three things. Sorry, he's crazy. He gets mad once we pet him. So the first one is area can be 1/2 little b times little c of sine A. Second one, area is 1/2 A times B of sine big C, or area is 1/2 A times C of sine big B. Okay, so notice one difference about all of these. And if you kind of know one of them, you can basically figure out the rest of them. Either their side lengths are used or the angle measures used. So if we already use B and C, it's going to be angle measure A. Side length AB, angle measure C. Side length AC, angle measure B. So this is a way that you can find the area simply using side lengths and angle measures, which, if you remember, generally we have to find a height or some sort of height when we're trying to find area. So this is one way that alleviates having to find that height. Sometimes in these triangles, that's something that's not given to you. So in a triangle, let's see if I can draw this out kind of accurately. This is supposed to be tilted back a little bit, so it's actually not 90 degrees. This is 102, 52, and 90. What I want us to label this as usual, A, B, C, A, B, C. So we have to determine what have we been given, so what kind of area formula do we have to use? So we are very clearly given angle measure A, which definitely already points me to this one. Do I have the other two criteria that I need? I do have a C side length, and I do have a B side length. So I have everything I need in order to perform the rest of this area equation. I'm going to erase the other two that I don't need. Let's fill in all the missing pieces here. So A equals 1/2 of 52 times 90 times sine of 102. So again, we go ahead and put this in your calculator, ensuring as always that it's in degree mode. Use all the parentheses necessary. We are getting a very large area, which makes sense because we have a very large side lengths here. A is 2,288.86, and we weren't given a unit here. But it would be that unit squared, right? All right, so again, that's area. Quick kind of formulas here. Essentially, you just take what you're given. Had I had another angle measure given, I could have just about used any of those formulas. You just use whatever you have in order to go ahead and decide which formula to use. Okay, but that is 6.1. Again, everything log sine. So coming up in 6.2, we're going to dive into a little bit of log cosine. Let me know if you have any questions. And if you need a calculator and you don't have one at home, again, as always, you can try desmos.com, or if you download the app Calculate 84, that'll work for you. Thank you.